Yesterday we talked about polynomials that when graphed will just cross right through the x-axis, or some, like right here, will bounce off of it. Okay, that's a bounce. This one just crosses right through. Now remember, a bounce actually counts as two zeros. We call it a multiplicity of two. A cross just counts as 1 0. Okay, it hit it one time at 1, and that counts as 1 0, but over here it hit it twice at -2. It was a bounce. Today we're going to be talking about what happens when one flattens out. See over here on the right side how it just went straight through it? That just crosses. So that 0 only counts once, and it's at +1. So we know that one of our zeros is +1. Now our other 0 is at -2. But that 0 is a multiplicity of 3. See how when you look closely, it doesn't just come down to the x-axis and then just go right across it. It lays down flat across the x-axis before coming through. That's a flatten out, and that counts as a multiplicity of 3, and that happens at -2. Because I look for the middle of where it lays. Okay, so we know that for this 1, that factor would be x minus 1, right? To produce a 0 at 1, the factor would have been x minus 1. To produce a factor at -2, it would have been x plus 2. But today, since it's a flatten out, you'll cube it. So now when you write them down here, you'll write x plus 2 cubed, and then x minus 1. If it flattens out, yes. If it bounces, you'll square it. If it flattens out, you'll cube it. If it just crosses straight through, it's to the first power. Okay, is that the whole equation? Are we done? Right, it's negative, so you have to put a negative sign because it's going down.
How do you get this?
Okay, let's talk about the degree for this one. Okay, first of all, is the degree going to be an even or an odd number? Even, and how do you know that? They're going the same direction. Same direction means even. So even like 2, 4, 6. Well, how many zeros do we have? 4. Look, here's 3 of them, and here's another one. That's to the first power. Okay, now open up your flip book, and let's do some more examples like these. Okay, up here, we can see that it's flattening out right here at -2. Okay, and when it flattens out, that is a multiplicity of 3. So when you write the factor for that, it would be x plus 2 cubed. Now over here, it crosses right through the x-axis at 1. So what would its factor be? X minus 1. So now, which one will we write first down here? Right, you always write the multiplicity one first, and then the other. Okay, anything else needed? We don't need a negative sign because our graph is positive. What is the degree? 4. We know it's going to be an even number because they're both going up. They're going the same direction. And look, 3 and then 4. Okay, you try this next one. Okay, we can see over here at -2 that it flattens out. So that is a multiplicity of 3. So how would we write its factor? X plus 2 cubed. And then over here, it just crosses through the x-axis at 4. So how would we write its factor? X minus 4. Okay, so down here on the equation line, which one would come first? Right. Anything else needed? What's the degree? 4. Right. Okay, we knew it was going to be an even number because they were going the same direction. And then this spot right here counts as 3 zeros, and that's the 4th one. Okay, go ahead and try this one. Okay, we can see that we have x-intercepts here, there, and I can't really tell if that's, because that looks a little close to that compared to these, so I really think it's about right here in the middle of it, which is at 4. Okay, this one's at special, any multiplicity? A bounce, which is a multiplicity of 2, and a flatten out, which is a multiplicity of 3. So the factor for the negative 2, what would it look like? X plus 2. The factor for the bounce at 0 would be x squared, and the factor over here? Right. Okay, so which one do we need to write first? That's what you would think, but anytime you're just dealing with a monomial, you would write it out front, because wouldn't it look kind of funny squeezed in between the two binomials? And then start with your binomials. And remember, this is a multiple choice test, so you just look for the choice with the right factors. It won't matter. I don't think they have two choices that had the same thing in different orders, but they would produce the same graph. Okay, now turn to page 12 in your packet. Oh, it's degree 6. Okay, look, here's 1, 2, 3, 4, 5, 6, and we knew it should be even because they're going the same direction. Look, here's 1, 2, 3, 4, 5, 6.
Oh, yeah.
And if you look at it down here, look, 2 and 3 make 5, and this one's the d to the first power.
Yeah.
Okay, so now turn to page 12. All right, number 1 on page 12. Given x squared plus 2x plus 3, choose the answer that best describes the polynomial. Well, first they want to know what degree it is. Is it degree 2 or 3? Raise your hand if you think it's degree 2. Page 12, number 1. Raise your hand if you think that trinomial is degree 2. Raise your hand if you think it's degree 3. How come you didn't raise your hands except for 2 of you? Okay, well, let's look at it for a second. Okay, let me make up a different trinomial. Let's see. Okay. This trinomial is degree 2. When you're looking at a polynomial that is not factored, see what I mean by not factored, and someone asks you the degree, you look for the highest exponent, and it's 2, making it degree 2. Now, what if somebody didn't give it to you like that, and they gave it to you in factored form? Okay, so two numbers that multiply to a negative 10 and add to a 9 would have to be a positive 10 and a negative 1, right? So what if they gave it to you like that instead of like that? It's also degree 2, because isn't this one to the first power and this one to the first power? So when it's not factored, you just look at the highest exponent. When it is factored, they've broken it down, and so you have to add up the exponents. Because think about it. They've taken that x and put it and split it up into two different binomials. So you have to add them up when they're factored. When it's not factored, you just look at the highest exponent of the problem. So now let's go back to that one in your packet. What degree is it? 2. So that eliminates b and d. And then the leading coefficient, is it 1 or 3? Oops, I meant 3 or 1. 1, because isn't the leading term x squared and its coefficient is an understood 1? So the answer would be C. Okay, so you go and try number 2. Next Thursday. Okay, what did you get for number 2? 5. The highest exponent is 5, so it's degree 5. What is degree 5 called? Quintic. Okay, under each graph pictured below, list the zeros. Okay, A. We can see that there are 3 zeros. Zeros are non-effects intercepts. And where are those 3 zeros located? Right. Okay, so go ahead and quickly do B and C. 5, -2, and 4. I wrote that back. Okay, and then what about C? Right. Okay, number 4, under each graph pictured below, tell the degree of the function. We're going to skip A for a second. Let's look at B. How many x-intercepts do you see? 1, but it's a bound, so it's a multiplicity of 2. So what's the degree? 2, and we know it has to be even because they're going in the same direction. Okay, also, isn't that just a parabola, and don't we know by now that parabolas are x squared? Okay, we're skipping C for a minute. Let's look at D. They're going odd directions, so we know our degree is going to be odd. It's going to be an odd number. And so what's the degree? 3. 1, 2, 3. Okay, E. Is it even or odd? Even. They're going the same direction. So you're thinking of even numbers. What's the degree? 4. And then F. 3. Okay, let me show you for those of you who thought 1. If I were to graph x to the first power, it would look like this, a straight line. Remember, x to the first power is linear. If I go back and change that exponent to a 3, doesn't that look more like our graph? Now, the reason some of you thought 1 is because you're like, oh, well, it's 1. But look, it flattens out there, which is a multiplicity of 3. Okay, now, well, just remember, y'all should start catching on to the fact by now that if it's just x to the first, it's a straight line. If it's x squared, it's a parabola. If it's x cubed, it's a snake. Okay, a cubic function looks kind of like a snake. X to the 4th. Okay, but by now you should be catching on to the fact for at least x to the first is like that, x squared is like that, and x cubed is like that. Okay, now let's look at A. What degree is it? Is it even or odd? Even, so you know it's got to be an even number, but it never crosses. But think about it. If you took this parabola and shifted it back down until it hit the x-axis, wouldn't it bounce right there, which is a multiplicity of 2? If you took it all the way down even further than that, wouldn't you see it cross 2 times? The reason we don't see it is because its solutions are imaginary. But we'll get into that in the next unit. What? I mean, think about it. When you find imaginary solutions, when you're doing like the work with the functions, then these are just the graphs of those functions. Okay, what about C? What degree? 3. That's a cubic function. Even though you don't see all 3, 2 are imaginary. 1 is real. Okay, now turn to the back. I want you to take a few minutes to try 5 and 6 by yourself. Okay, number 5, for the graph shown below, list the intercepts in A. Okay, well, where are the intercepts of that graph? Okay, anything special?
Yeah, it flattens.
Right. That 1 has a multiplicity of 3 because it flattens. So, how would I represent that in a factor? Well, the multiplicity would come first, so
Negative 1.
cube because it flattens out. And then, right. Shh. Guys, focus, we're almost finished. All right, number 6. Where are the zeros? Okay, anything special? Right, we have a bounce at 2. Shh. Eric. So what do I write? And then, okay, is that the whole thing? You sure about that?
No, there's negative.
Negative, because from left to right it's going down, so don't forget about that leading coefficient sign. Okay, we're finished.